Hi, folks. We're going to test this system today. I'm going to take these 2 points and we're going to do a few things with them. We're going to find the slope first, then the distance between them, then estimate the y-intercept looking at the graph, and then find the y-intercept algebraically, then write the equation in slope-intercept form. So there's a lot of things happening. We're also going to find the midpoint, and we're going to write the equation using point slope form. So all of those things are going to happen today. Let's start by taking 2 points, and we can find the slope between them. Now, our slope formula, of course, is y2 minus y1 over x2 minus x1. Those are subscripts, not exponents. Just keep that in mind. And all we have to do is substitute. We've got a y2 minus a y1. So I'm going to call the first point, x1, y1, the second point, x2, y2. So we're going to find, by substituting inside parentheses, y2 happens to be 2, minus y1, which happens to be negative 6. Now, I generally don't put the parentheses, but that's bad habit, so we're going to go ahead and do it this time. Now, x2 is 4, minus x1, which is negative 2. And notice that we have double negatives here. When you see a negative in front of a parenthesis, it's as if you're multiplying by negative 1. So this is a positive 6, and I read this 2 plus positive 6. Subtracting is the same as adding the opposite. So we're looking at 2 plus 6 is 8 over 4 plus 2, which is 6. Now let's graph our 2 points and take a look at that slope physically. So C is at negative 2, 1, 2, 3, 4, 5, 6. This is the point C right down here. And the point D is at 4, 2. 1, 2, 3, 4, 1, 2. We call that the first quadrant. And we're interested in counting the slope from C to D. Notice that to get from C to D, we have to go up 8. That's 1, 2, 3, 4, 5, 6, 7, 8. That's why we have a positive 8 in the numerator of our slope. This is positive 8. And we, sorry guys, there it is. And then we go to the right 6. 1, 2, 3, 4, 5, 6. I went off a little bit on that one, sorry. There it is. Get rid of that for a second. We'll just pretend like that's a big point. All right, now we are looking at up 8 over 6. Just keeping in mind that I can also count backwards. I can go down 6 and down 8 and back 6, and it's the same thing. In other words, this is the same as negative 8 over negative 6. A negative divided by a negative is a positive. But it just so happens that if we had chosen the other order for our points, we would have gotten this, so we want to keep that in mind. Now, I'm going to label this diagram. This is 8 units long, this side over here, and this side is 6 units long. And some of you may have realized that this is a right triangle. If we want the distance from C to D, we can treat this right triangle just like it is. It's a right triangle with legs of 6 and 8. Notice that the legs have a right angle between them, and it points at the hypotenuse. This is the hypotenuse, this long side. This is the distance I want to find. We sometimes call that CD. CD is the distance between C and D. Well, I have a diagram, and my next step is to write a formula. A squared plus b squared equals c squared, which is the Pythagorean theorem. It tells us that the sum of the squares of the legs is equal to the square of the hypotenuse. We're going to substitute. Instead of A, I'm going to use 6. Instead of B, I'm going to use 8. And this is going to be my distance between my points, so I'll just use d squared. Some of you are familiar with the distance formula. This is where it comes from. Notice that my 8 came from subtracting the y's, and my 6 came from subtracting the x's. The distance formula generally is, y2 minus y1 squared plus x2 minus x1 squared. Take the square root of the whole thing. We're going to simplify this a little bit. 6 squared is 36. This is the simplification step. 8 squared is 8 times 8, 64. And it's equal to d squared. And we can simplify it even more by adding these together. We get 100 is equal to d squared, the distance squared. Now we want to know what number squared is equal to 100. And there's actually two solutions to this, but we're only interested in the positive part. And I'm going to solve by taking the square root or asking what number squared gives me 100. And the way we ask that question is with this radical symbol. What number squared gives me 100? Well, we know that 10 squared is 100. So the distance between these 2 points is exactly 10 units. Now, one of the things I have my students do is to use a piece of graph paper and actually measure the distance between C and D. These squares are 11 long. This is x coordinates, and it's 11 long. Notice that from C to D, I'm going almost exactly 10. There it is. Hopefully you can see it. This is 10 units right there. Now, the second thing I said we were going to do is we were going to look at the Y-intercept. Well, the Y-intercept looks like it's really close to -3. Did I miss that? Oops. Got to take my glasses off on occasion. Sorry, guys. Here we go. This will look a little better. There it is. I missed my point. I still missed it. Man, can't seem to hit it just right. Oh, well. It's in between the -3 and the -4. If you are following along at home and you drew this diagram, you're going to see that my y-intercept is really close to -3, but it's not exactly -3. And a really good way to find it is to use the equation y equals mx plus b. And we can choose a point. I'm just going to choose this point that's on my line, and I'm going to use my slope, but I'm going to go ahead and reduce this slope a little bit so it looks a little nicer. 8/6 is the same as 4/3, and we sometimes call that m for the slope. So I've got a slope of 4/3, and I have a point of 4, 2. This is x and y. So I'm going to put the y where the y is. I'm going to substitute. Where the m is, I'm going to put the 4/3. Where the x is, I'm going to put the 4 plus b. Some of you might be aware that there is an invisible 1 underneath this 4. I'll go ahead and put it in green. We can actually still see it, but here it is, over 1. And when we multiply, we get 16/3. Now, a lot of people, this looks really scary. This is one of the few cases where I think a mixed number is okay to use. 3 goes into 16 5 times with 1 left over. You could have subtracted the 16/3 from both sides, gotten a common denominator, and you would get your answer. For me, I'm going to go ahead and subtract 5 1/3 from both sides. Of course, it's really adding a -5 1/3. Same thing. Adding a negative is the same as subtracting. Well, I have a +2, and these two positives kill off 2 of these guys. So there are -3 1/3 left. And that is my b value. So -3 1/3 is b. And then I can write my equation. in slope-intercept form. Y equals 4/3 x minus 3 1/3. In general, we don't usually like mixed numbers in algebra. It's a little easier to use if you just put it back into a fractional form. I know they call it an improper fraction. 3 times 3 is 9, plus 1 more makes 10/3. If you want to see a picture of that, it's 1, 2, 3, and 1/3. I'm dividing these into thirds, and I have 9 of them, which makes a total of 10/3. Thought I'd throw that in there. So this is also the same equation, of course, 10/3. This is probably the one that your teacher is going to be looking for. However, there is a much, much easier way to write the equations of a line if you have a point and a slope. And we call it the point-slope form. So we're going to examine the point-slope form of an equation. Now, your teacher or your professor is probably going to write it like this: y minus y1 equals m times x minus x1. Now, rather than thinking about this and substituting, I prefer to think of it as zeroing out my point. So I'm going to take this point, I'm going to take that same point, 4, 2, and that same slope, 4/3. And what I'm going to do is I'm going to force this 4, 2 to be a solution to my equation. And the way I'm going to force that is I'm going to zero out this 2 by doing this, y minus 2. You can see that that's what I did there. Equals 4/3. And then I'm going to zero out my 4 by taking x minus 4. And what we've done is we've created an equation that has a solution 4, 2. Here's the proof. If I put a 4 for x, we can see that it gives us 0 on the right. This whole thing is 0 if x is 4. And this whole thing over here is 0 if y is 2. So we know that this point is a solution to this equation. We can also see that the 4/3 is a coefficient in front of x. It's going to get distributed to this 4 over here and give us the negative 16/3, and then we're going to add it to, we're either going to add the 2 to both sides. It's going to be actually negative 16/3, but it would work out anyway. This equation is in what we call point-slope form, and it is exactly identical to this one. It is so much easier to do it that way. So I always prefer point-slope, but both of these equations are equivalent. We have one last thing, and that's to look at the midpoint. The midpoint between 2 points, if we have 2 points, and we do here, is the average of the x's and the average of the y's. When we take an average, we just add them together and divide by 2. We add them together and divide by 2. And it looks like this. The midpoint is x1 plus x2 over 2. And y1 plus y2 over 2. And we get the midpoint. So I'm going to add my x's together. Negative 2 plus 4 over 2. Notice this isn't an equal sign. There's nothing going on. It's just an ordered pair. That's all that is. That's why it has the comma between it. I'm going to add my y's. Negative 6 plus 2 over 2. And then I'm going to add these together. Negative 2 plus 4 is 2, which gives me, I don't know where to put it. I'll put it over here. I ran out of room. 2 over 2. And negative 6 plus 2 is negative 4 over 2. And finally, we can get our point, which is 1. 2 divided by 2 is 1. And negative 4 divided by 2 is negative.